All right, welcome back to this lecture series on data architecture. Today we are going to discuss about data storage. Yesterday we discussed about data sources and data ingestion, and we just picked up one of the data sources, that is RDBMS systems, right? Databases. I know there are multiple others like Kafka and file systems and SaaS applications. Maybe we'll cover them later. The first, let's try to complete end to end design using very simple components, and then as we progress in this lecture series, right, we'll keep on adding the other aspects also. I'll try to number it accordingly, like yesterday's session or session 2. Maybe whenever I talk about Kafka and the other sources, I'll rename, or I'll name them as maybe 2A, 2B, so that it is easy for you to find these when you're browsing through the playlist. So there's a separate playlist also which I've created for this, called as lecture series. Let's start with today's session. So if you remember from the first session, right, we spoke about a data platform where we have data coming from source systems, we ingest it, it gets stored somewhere, and then we do the processing, and finally the data is consumed from the storage. Right, this is a very high level basic diagram that we are discussed. So today we are going to talk about the storage part, right? Now, we are talking about the analytics world, right? We are not talking about the OLTP. OLTP is the online transaction processing, where which are the backends of systems like your banking applications, your library management, ticket management, right? Those are the backend systems. Those are the OLTP systems. We are here dealing with, when we are talking about these cloud data platforms, we are only talking about the data analytics world, right? We are not talking about the online transaction processing. So when it comes to the OLAP world or the analytics world, there are different architectures, there are different architectural patterns to store the data, right? And the most popular among these are, the first is the data warehouse, where you can store the data, right? This was very popular since the 1990s, I would say, till 2000, 2010. Then people started using data lakes, right? Data lakes are, um, uh, uh, because of the Hadoop, right? With the rise of Hadoop and social media feeds, organizations started implementing data lakes. This was somewhere around 2010 onwards. Then there was a combination of data lake plus a data warehouse, right? Late 2017, 18. This was the approach which was most adopted, right? Maybe 2017, 18, I would say, onwards. Depends on organization to organization, and then currently, right, the most popular one is lakehouse, right? Data lakehouse. I would say 2020 onwards, most of the organizations are implementing this. So we are going to talk about each one of these one by one. In today's session, I'll cover data warehouse. Okay. All of these are still very relevant in the today's world. It's not that people are only building data lakes or only building lake houses. Still, it depends on the organization. What are the use cases? As an architect, you should know all these things so that you can recommend the right architecture. Though yes, like a lake house addresses most of the challenges, and it is now become the default choice. But as an architect, you should be aware of all the other architectural patterns also. So yeah, let's talk about the data warehouse. Okay. So um, maybe, right, somewhere around late 1980s, early 1990s, organizations started using these. And if you have been working in data world since that time, right, you would remember reading a lot about warehouses, and how all the data modeling is done using in the data warehousing world, right? Bill Inman is known as the father of data warehousing. He has written a lot of books he about data warehouses, how to build data warehouses. Even till today, right, he has been writing a lot about not just data warehouses, even data lake houses and the other architectural patterns. So yeah, I would strongly suggest you to go through his books and his blogs on LinkedIn as well. And then Ralph Kimball, right, he introduced the dimensional modeling. So those who have worked in that era, right, early 2000, they would be aware of these. So we'll discuss it at a high level, right? Like what are things are there, as a data warehouse, how it is relevant in today's world, how you can implement a data warehouse even right. So data warehouse, right, during that time it was all about structured data. Okay, so a couple of decades ago we only dealt mainly with the structured data. So source systems, right, like files or databases, these would send data, right. These, let's say, these are the source systems or the OLTP systems. In case of databases, there was something called as ETL, extract, transform, load, which we would do and eventually load the data into the warehouse. We'll talk about ETL in the next lecture, right, when we talk about the processing part, right? This part we are going to discuss more about ETL, ELT, and all those processes there. As of now, let's concentrate on the warehouse part. So we are here, right? We are going to talk about this warehouse. So it was all about the structured data, and then why we needed a warehouse, or why we need a warehouse, right? So see, it is mainly a system which can support your analytical, use cases, or your use cases where you want to generate BI reports, business intelligence. We also used to call it, right, decision support systems, DSS, MIS reports, right, management information system. So for all the reports or dashboards, right, where you want to see historical data, right, this is the keyword, historical data, like what happened in the last quarter, what happened in the last year, what is the sales in a particular region, year on year, right, compared to the last year, how much is the sale now, right, across various dimensions, right. So if a company, if an organization has various, let's say let's say a company which is into retail, right, it has stores across the world. Okay, it has various stores across the world, and it is selling different products. So if you want to do such analysis, right, which was the store which sold a particular product the most in the last quarter, right, always it would be against some time dimension. So that kind of things you can get it, by using like a data warehouse. So all this data is stored within a data warehouse. All your historical data is stored within a warehouse, and you can get these reports out of that. So what were the technologies used that time, right? So there were specific appliances. When we talk about warehouses, right, we used to get warehouses as appliances from, like, let's say, Neteza, Teradata. The other popular ones were Hexadata from Oracle. So what does that appliance mean, right? It was a combination of software as well as hardware, and these were all high end hardware. Okay, so it was not like commodity hardware, right? The word, this commodity hardware, you must have heard a lot about Hadoop. We'll talk more about it during the data lakes discussion. So here, right, in warehouses, we used to get these appliances, and it was like quarter rack with all these servers, along with the software. Eventually, if you look at the software, right, the underlying technology, it was still RDB based. Okay, so many times people get confused, like what is the difference between a database and a warehouse. So see, eventually database and a warehouse, right, the technology is same. It's the same RDBMS, that as a software that you are going to use. But database is more about, having your data from your applications. You have a lot of siloed applications, internal systems which are stored in the database. In warehouse, it's like you are going to store all the historical data, and then it would have a good hardware, as I said, like the appliances and all. These are hardware which can support your, heavy processing, because all the analytics, all the BI that you need to do, it had to churn a lot of data, which was the historical data, like 5 years back, what was the data, and you want to do some lot of aggregations on top of it. So usually it came with a lot of, high-end hardware also. Um, Things like Teradata and all, it was based on the MPP hardware, right? MPP as in massively parallel processing. There would be, different nodes across which the processing bit happened. So even in today's world, right, these all things are very relevant. You can still make warehouses. Okay, so some of the most popular ones are, I would say Snowflake. I think most of you would be aware. Redshift, okay. Azure has Synapse. When we talk about Synapse, it is the Synapse dedicated pools. Okay, these are all cloud data warehouse, right? Previously, we spoke about these were popular as in on-prem data warehouses. Nowadays, we have the cloud data warehouse. Again, Snowflake does much more than a warehouse these days, right? It's a complete cloud data platform. But then initially, when it started, right, it was only Snowflake as a warehouse. Similarly, now Databricks also has a Databricks SQL. You can create a warehouse on top of it. But to keep it simple, I'll just talk about giving an example with Snowflake or Redshift. Now, these are the two popular warehouses, I would say, which were used earlier. Okay, let me just scroll up a bit. Yeah. So what would happen here, right? You would take the data from the source system. You would do something like an ETL or ELT, and then store the data into the DWH. In our case, let's say it is a Snowflake or Redshift. Okay. Now, one main difference, right, when which I think I missed talking about, and it is an important concept, right? You need to understand something, right, between a data warehouse and a database. It's the way the data is stored, right? In database, generally you will see it uses row storage, okay, row based storage, and warehouses use a columnar storage or column based storage. Now, what's the difference, right? See, database were meant for transactional processes, right, where a lot of transaction are happening every minute or every second. Lot of writes and updates are happening. Yeah, whereas warehouses, right, you won't see a lot of updates happening. It is more about read only queries, analytical queries, where you are trying to select data from a larger volume of historical data, right? So warehouse queries, how does it typically look like? Like, let's say you have a customer dimension and it has, let's say, 50 columns, right? But when you do a query, right, as a warehousing query, it will be select, not star. It would be just two, three, four columns, maybe just 10% of that. Let's say just five columns. So you might be saying, okay, what is the count of customers whose age is greater than 50, something like that, or you are going to aggregate this data. What is the salary of employees from a particular department, right? So here, the queries, the pattern of the queries in I'm talking about a warehousing OLAP kind of queries, right? BI queries is such that you don't have to fetch all the columns. It would be just around 10 to 20% of the overall column. So if a particular dimension has 100 columns, your generally queries would be extracting 10, 15, 20 columns only, not all of them. Whereas in a database, right, because you are inserting the data, you are updating some data, it's going to hit all the columns, and that's why databases generally use row-based column, whereas warehouses use columnar storage or column-based storage. Now, what's the difference? If you'll see, get a lot of videos for this. I think I have also created one maybe a couple of years back, but I'll just quickly explain this. In row-based storage, right, the data actually physically gets stored as a row. So let's say you have a column A, 111 and PQR. This is your row 1, and the row 2 is P222 and XYZ. Now, when this gets stored, right, in your row based, it will be stored as is, like a row. A111 PQR, second will be B222 XYZ. Okay, so this is how that storage happens. So actually it is storing it row by row only, okay. But whereas in a column based columnar storage, right, which are in warehouses, the data gets stored at the column level. Okay, so I change the color, it will get stored. So this is how it will get stored. Okay, so A comma B, right, or I won't say A comma B, or A and B gets stored like together. 111 222 gets stored, and then PQR and XYZ. Okay, now why it is like this? Okay, why, how does it help? The thing is, see, as I said, right, when you're fetching, it is just going to fetch few columns in your BI kind of queries or OLAP queries. So if you just want to see this column, right, this was the amount column and you want to see the amounts, you can just fetch this column and it will, that IO, right, it reduces, that data scan is reduced, because you just have to hit this particular data block, right, which is stored in your system, and you have to fetch it. Whereas here, right, because it is stored, this is one block, this is another block, if you still want to fetch 111 and 222, it has to read this whole thing, then read this whole thing. Now imagine if there are 100 columns, right? So it has to read this, all these 100 columns. And so that is the reason all this data warehouses, right, use columnar storage. Okay. So it helps to fetch data easily because we are just dealing with few columns, not all of them. Second, it reduces that data scan, the IO operations are lesser. Third, it also helps you to compress the data because it is of the same data type. See, if you want to compress this data, row based, right? This is string, this is integer, this is string, it becomes very difficult. But when you have data of the same type, the compression becomes much easier. So the storage, the volume that it occupies, it's also much lesser in columnar storages. Okay. A simple example that I generally like to give in my training classes and all is, look at it this way: you are trying to store different fruits in a wine jar. Let's say you have oranges and you have watermelon and different fruits. You cannot really store them effectively in a single container. But if you sort them, if you keep your oranges separately and your watermelon separately, it becomes much easier. It's a similar, just for an analogy I wanted to talk about it. So yeah, that's the difference in a database and a warehouse or storage. Okay. Now that you understand this, right, all the modern warehouses use this columnar storage, right, be it Snowflake and all the other ones. Now one important thing is, when you are going to store the data into the warehouses, right, let's talk about Snowflake. uh, this is a modern warehouse or the cloud data warehouse. Okay. You also need to understand some of the important concepts that come with it, right? See, storage. Why we are talking so much about storage, right? See, one is, you always have to understand what are you ingesting, okay, and what you want to consume. Okay, everything in between is the processing. Okay, so what is your ingestion? You are storing a lot of structured data and you want to consume it as a BI report or OLAP kind of a workloads, right? For that, warehouse is one of the best ways to do these things, right? Let's say you don't have any AIML requirements, you don't have any requirements for unstructured data, you don't have requirements for real time data. Nowadays, all these use cases also supported by Snowflake. But traditionally, right, 10 years back, 20 years back, the typical warehouses won't support these kind of use cases. But now most of them are started supporting these as they have become a cloud platform. But let's say you just have a structured data, you are working for an customer or an organization which don't have a very large volume of data or maybe they have a large volume of data, but this is all structured data. You can still suggest using something like a simple warehouse. Okay, Snowflake just as a warehouse, maybe Databricks just as a DB SQL as the warehouse. You don't really need other things like Spark and all those things, right? So you need to consider, based on a use case, what you want to do. Of course, you'll have to think about the future use cases and a lot of other things. But I'm just telling you where things like a typical cloud data warehouse is even comes into today's world. And it becomes very simple, right? Anything related to where you just have to use SQL, it is much simpler. So yeah, that is one thing. Now, maybe you should pick up a separate course for Snowflake, but at a high level, all this modern warehouses, right, one thing that they are doing, or the modern architecture, there is a separation between your compute and warehouse. Okay, this is important. There is a separation between your compute and, sorry, not warehouse, compute and storage. Okay, sorry about that. So see, previously, right, if you remember, like for a database, let's say you have created a Oracle database, you would have to store the data inside that and use its own compute engine. um, if your disk space is full, you will have to go for another instance, and you will have to increase that space, all those things. because this was tightly coupled. Okay, the previous generation databases or the even the Hadoops of the world, the Cloudera clusters, right? That time your machines, right? Your, let's say this is the compute and this is the storage. This was tightly coupled. Okay, this was the case some 4 5 years back, till 4 5 years back, almost till 2015 16. Generally, we are working with such kind of architectures. Nowadays, this is the fundamental to everything. Your compute and storage should be separate so that you can scale them independently. You don't want to tightly couple them. So let's say you are currently using a compute which is like 4 vCPUs and storage is 1 TB. Now let's say you want 8 vCPU. Now you don't want to increase your storage because of that. You should have that flexibility that you can just increase this and keep this as 1 TB, or vice versa. If you want to increase this to 2 TB, you don't want to increase your compute. That flexibility you want, and this get you can get it when we use an architectures which have decoupled your compute and storage. And now like with Snowflake, that is possible. In fact, with a lot of others also, everyone is now using this. Okay, I'm just giving example of Snowflake. So what Snowflake does, it will give you the compute using the virtual warehouses, and eventually, though the storage is managed by Snowflake, it uses the cloud object storage. Okay, cloud object storage. Now remember, this is the most important one. Most of the organizations today are shifting to cloud object storages to store everything because it is cheaper. Cloud object storage is in S3, ADLS, GCS, right? Because this is much cheaper, highly available, highly scalable. Okay, so we are slowly moving towards it, putting everything into the object storage. So Snowflake also does the same thing. It is storing the data into this, but it is managed by Snowflake. Okay, so it's like we have separated the warehouse and storage. So if you work on Snowflake, you will know you can have the same database attached to multiple computes. You can increase your compute. You can go from Access to medium size, Excel size. It has this T-shirt sizing warehouses. All these things are possible. Why it is possible? Because the storage is separated. You can attach a database to any of the warehouse and all this thing, and it enables a lot of other things, right? You can do sharing also. A lot of things are possible because of this. Now this separation of compute and storage, we are going to talk a lot about it during our lakehouse session as well, because there things are bit different. Here the only right limitation I would say is, see, though you have compute and storage separately, like if you have stored something in Snowflake, you have to move the data. Let's say you have ingested data from a Postgres, right? Postgres, and let's say you have put it into S3, and from S3 you have to move it to Snowflake. So there are two copies. You are putting the data into S3 and you have to copy it into Snowflake. So here, right, for Snowflake, or for that matter any warehouse, be it Redshift or be it Synapse dedicated SQL full, in the warehouse world, you have to copy the data inside that warehouse, inside its storage. And this storage, right, you cannot access it from um, any other computing, right? If you have data inside a Snowflake, you have to query it only using Snowflake. You cannot use any other engine. Now again, they have Iceberg, they have introduced it, but let's not get into that. That's a bit more advanced thing. We are going to talk about it later. But if you look at Snowflake, before the open table formats, uh, it has its own proprietary storage. Data would be stored inside that, and you can query that, but you cannot query that using the Snowflake's virtual warehouse, the compute. You cannot query it from any other compute engine outside. Okay, now why do we have these proprietary things and all? um, See, it is all the performance, right? Most of the performance is at the storage layer. The magic happens at the storage layer, not really at the compute. Yes, compute and caching and memory and all are important for your performance and all, but a lot of things have happened at the storage level, because if you are storing the data in such a way that it is easier to retrieve what you really want. Okay, like it's like let's say you have a lot of data, right? This is your data, let's say 10 TB of data, but you just want to pick up 1 GB of data, which is, let's say, this. Okay, this is the 1 GB of data that you now you don't want to scan this entire thing. You just want to go here and pick this up, right? So how that would happen, right? All these things are done at the storage level. In Snowflake, there is a concept called micro partition. When it is storing the data, it's going to store them into micro partitions so that when a query engine comes in, let's say these are all micro partitions, 1, 2, 3, 4, 5, 6, all these things. The query would know, okay, I just have to go and pick the data from here, or at the max from here and here and here. It has to scan only these three. So this is all the things which the storage does. Okay, so sometimes these are not very transparent. So if you're using the Snowflake's internal storage format, which is proprietary, you won't know what is happening. But yeah, they use the micro partition concept. You can have a look at those videos in more details to understand how all these things are done. Okay, but eventually what you want as a performance, to gain the performance, you want to reduce your data scans. You want to fetch only those blocks of data where, or you want to scan only those where data would be present, might be present, right? And these concepts are generally called as, data skipping or pruning, file pruning, partition pruning, right? Those who have worked on databases, they would know, right? Let's say you have a table which is partitioned on monthly basis. Okay, you have a table, let's say it is partitioned on monthly basis. So 1, 2, 3, these are the months, right? Jan, Feb, March. So if you're looking for a date, like today is, let's say 7th March, you want to get data for 7th March. If you put in your where clause, if you put this month as, March, it is only going to go and fetch the data from here, not from these things, right? Now why that is possible? Because it is partitioned this way, right? So eventually it is the storage. So Snowflake, right, with this proprietary storage, they had given all these things, so you don't have to worry about it. So warehouses, right, so they are really good at all these things. The BI queries are very very fast. They are blazing fast with warehouses. So if you still have the question like why warehouse as compared to database, columnar storage, you can pick up only the columns that are required. The queries are much faster. If you compare data warehouses with data lakes, again data warehouses are, it has metadata which is more managed. Your BI queries are much faster. It is easy to discover data, right? It has a lot of advantages. So even today, as an architect, right, if you're looking at storing your data, your question should be, what you should be thinking is, should I use a warehouse? Should I use a data lake? Should I use a data lake or a warehouse? Should I use a lake house? All these things, right? You have to think about all these things. As I said, right, maybe lake house might be the default way of doing the things. Open table formats is going to be the default way of doing the things. We are going to talk about all these things in our subsequent lectures, but then uh, if you have not worked on these things, at least you should start reading about it. If you're an architect who have directly jumped onto the open table formats of the lakehouse, it's good to know about the history, not the history but how things worked, right? Only then you would be able to appreciate all this new technologies and how things are working. So I think we should stop today for today. Maybe tomorrow we'll talk about data lake or something else and continue with this. If you have any questions, suggestions, please put that into comments. If you want to have a one-to-one with me, you can connect me on Topmate. I have free one is to one connects there. And by the way, I'm also part of the AWS company builder team. So I have few credits, $20 credits, which I'm giving away. If you want to try out any of these using AWS services, do ping me on LinkedIn. I'll give you that $20 credits, $20 per person. Okay, that's the limit. So yeah, thank you for listening and see you soon. Bye bye.